Alright, hi everybody. Today we're going to talk about Objective 3.7. Objective 3.7 is about classifying triangles and determining the relationship between a triangle's sides and angles. So, you're going to learn what classify triangles means in a little bit. Okay? So, I hope you guys recall from middle school, the sum of the measures of the angles of a triangle are always going to be equal to 180 degrees. If I have a triangle, right? If I have a triangle, if I add all of the angle measurements up, this angle plus this angle plus this angle, our angle measurement is always going to equal 180. Okay? So, if I add all of them together, it's going to equal 180. How many degrees are in an acute angle? Well, acute angles, recall, are less than 90 degrees. We learned about that all the way back in 3.1. Now, what about in a right angle? Right angles, recall, have measures of 90 degrees. Exactly 90 degrees. And an obtuse angle has measure that's greater than or more than 90 degrees. Alright? So, all triangles have at least two acute angles, meaning that two of the angles are always going to be acute, and then the third angle is going to determine what type of triangle it is. We're going to talk about that right now. So 3 ways to classify a triangle by its angles. So pretty much the key words here, acute, right, and obtuse, are the same that we've dealt with in 3.1, except now instead of acute angle, we're going to say acute triangle. A triangle is an acute triangle if it has 3 acute angles. So all of its angles are less than 90 degrees. A right triangle is 2 acute angles and 1 right angle. So a right triangle always is going to have 1 right angle. And an obtuse angle is going to have 1 obtuse angle. Now, next unit is going to be all about right triangles. We're going to spend a couple weeks on only right triangles and doing all this different fun stuff with right triangles. Alright, but for now we're just going to be able to have to classify them, okay? So, can a triangle have 2 right angles? The answer is no. The reason is because if it had 2 right angles, it would add up to 180, and then there would be no room for another angle. Because, remember, the sum of all of our angles in a triangle is equal to 180. So if I have 2 right angles, then that doesn't leave me any space for any other angles. Now, can a triangle have 2 obtuse angles? The answer is again no, and the reason is because again our sum is going to be greater than 180. Sum of all the angles sum is going to be greater than 180, and that's no good. Can't have that. Alright? So that's the 3 types of triangles, classifying it by its angles. Now we can also classify angles by its sides. Okay? So a scalene triangle, that's a triangle with no congruent sides. An isosceles triangle is a triangle with 2 congruent sides, and an equilateral triangle is a triangle with all of the sides congruent. Remember that congruent means equal in measure. So we're going to talk about examples in a few minutes, okay? Now, some important facts that we need to be able to recall. Now, these right here, we're going to touch upon these more in the next lesson. Okay, but for now, we're just going to talk about them, do a couple examples, and then you're going to practice this tomorrow on your own. So, the side opposite the largest angle is the largest side. The side opposite the smallest angle is the smallest side. The angle opposite the largest angle is the largest side. And the angle opposite the smallest side is the smallest angle. So I just said a lot of words there, and they all kind of maybe melted together. But I'm gonna break this down piece by piece for you in a few examples in a little bit, and you're gonna practice this tomorrow, okay? So notes on isosceles triangles. In an isosceles triangle, 2 sides are congruent. We talked about that right here. Therefore, 2 angles are congruent, and those 2 angles are called the base angles. So if I have 2 congruent angles, that means I'm also going to have 2 congruent sides. Okay? The angles opposite the congruent sides are also congruent. Okay? And the remaining angle is called the vertex angle. So that's just some important vocabulary. So if I'm looking at, So if I'm looking at an example of an isosceles triangle, okay, these little lines right here means that these sides are congruent. The sides that I'm tracing over are congruent. And then these little swooshes right here mean that these angles are congruent. We've seen that before in this unit. Now also recall from this right here, from this little fact right here, the angles opposite the congruent sides are also congruent. So this angle right here is opposite this side. This angle right here is opposite this side. So these angles are congruent. They're base angles and they are congruent. So now let's put all this together. So first of all, it says homework. Don't worry about it. It's not homework. We're going to do it right now. So find the measure of angle x. So here, this angle is 50 degrees. This angle is opposite this side. And since this side right here is congruent to this side right here, that means that x also has to be 50. Our base angles have to be congruent. These two angles right here are our base angles. In an isosceles triangle, our base angles are congruent. Now find the measure of angle y. Well, I know that this is 50, this is 50, and I don't know what y is, but I do know that the sum of all my angles has to be 180. So if I take that fact and I say, okay, well 50 plus 50 gives me 100, and I know that my sum has to equal 180, if I subtract 180 minus 100, I'm going to get 80 degrees. So that means that y has to be 80 degrees. Okay? Now classify the triangle by its sides. This is an isosceles triangle. Okay? The reason it's isosceles is because it has two sides congruent. It has two sides congruent. Classify it by its angles. This is an acute triangle. The reason is because all of its angles are acute. All of the angles in this triangle are less than 90 degrees. So we can also say that this triangle is an isosceles acute triangle. Okay? On your delta math, you're going to have to, on the delta math that you're going to do, you're going to have to classify angles like that with both of them together. Okay? Isosceles acute, isosceles obtuse, whatever the case may be. Okay? Now, name each triangle according to the length of its sides. So when we are classifying triangles, there's two ways to do it. We can classify it based on its angles or based on its sides. So we want to do these problems and refer over here to these three different types of triangles right here. Scalene, isosceles, equilateral. So here, number 5, this is a scalene triangle because none of the angles are congruent. Number 6, this is an isosceles triangle because 2 of the sides are congruent. Number 7 is an equilateral triangle because all of the sides are congruent. Okay? Now number 8 through 10, classify the triangles according to the measure of its angle. So here, what you want to do is you want to find the largest angle in all the triangles and see what type of angle that is. So number 8, its largest angle is 110. So since that angle is greater than 90, this whole triangle is going to be an obtuse triangle. Okay? Number 9, our largest angle is 90. Since 90 is a right angle, this triangle is going to be a right triangle. And in number 10, 80 is our largest angle. And since that is less than 90, this is going to be an acute triangle. Alright? Now 11 and 12. Name the shortest and largest side of the triangle. Here, we need to recall these facts right here that I circled in blue. Okay? The side opposite the largest angle is the largest side. So, the largest side, or the longest side, is going to be opposite the biggest angle. So my biggest angle here is 82. The side that is opposite 82 is AC, so that's our longest side. Okay, remember when we're naming line segments, we put the line on top with no arrows on both ends. Our shortest side is going to be opposite our smallest angle. So our smallest angle is 39. So the side opposite that is going to be AB. And last but certainly not least, for number 12, now we want to find the smallest angle and the largest angle. Okay, this should say the largest, not the longest. Okay, so the smallest angle is going to be opposite the smallest side. So the smallest angle is going to be opposite the side that's 22 inches, or our smallest length side. So that's going to be angle C. And our largest angle is going to be the angle that is opposite our longest side, or angle B. All right? So guys, I know I went a little tiny bit fast, but this was just meant to give you a taste of all these different theorems. All right? If you have any questions, as always, please let me know. Have a wonderful day, and I look forward to seeing you soon.